Welcome to the second video for section 5.3. So now that we've derived all of the angles, all of the trig values of the angles, we are going to be able to find the exact value without using a calculator because we memorized them. So for example, in number 4a, we have 2 times the sine of 45 degrees plus 4 times the cosine of 30 degrees. So I also told you before you need to memorize how to go between radian and degree measure for common angles. So we know that this is asking for 2 times the sine of pi over 4 plus 4 times the cosine of pi over 6. If you forgot, you use the conversion that pi radians equals 180 degrees, okay? And now because we memorized, we know the sine of 45 degrees is root 2 over 2. And we know the cosine of 30 degrees is root 3 over 2. And so simplifying our answer, we get root 2 plus 2 root 3. Okay, so this is just like one small step, but it's applying what we did previously. Okay, so next problem, sine of pi over 6 times tangent of pi over 3. Sine of pi over 6 is equal to 1/2. So if you forgot, I don't think you should forget, but if you're still trying to memorize these as you watch the video, just keep in mind, as I said, keep in mind the triangle, and then you'll have everything you need. Okay, so sine, and then you just remember this triangle, and you remember SOHCAHTOA. So I know the sine of pi over 6 is the opposite over the hypotenuse, so that's the 1 over 2. And the tangent of pi over 3 is the opposite over the adjacent, so it's root 3 over 1. And then you just simplify by multiplying these together, and you get root 3 over 2. The ones will cancel. Okay, so as you practice, then you'll memorize them. It's hard to really memorize things just straight. Okay, so there you go. So there's just the 2 triangles that you can concern yourself with. Okay, then when it comes for tangent of pi over 4 plus cotangent of pi over 4, so this time we have this other triangle with pi over 4 in both of the angles. So for example, if we have the hypotenuse to be 2 again, then this will be 2 over root 2 and then 2 over root 2. So you remember it like that, for example. Now we can see that the tangent of pi over 4, which is the opposite over the adjacent, is root 2 over root 2 over 2 over root 2. That's 1. And then the cotangent is the reciprocal of tangent. So that's 1. So totally 1 plus 1 equals to 2. Okay? So next problem is 4 plus tangent squared of pi over 3. So I need to do 4 plus whatever the tangent of pi over 3 is squared. And the tangent of pi over 3, let's look at the triangle above, and we know the tangent of pi over 3 is going to be the opposite over the adjacent. So it's root 3 over 1. Okay, so totally we have to square that to simplify. So I have 4 plus 3, which equals 7. Okay, so that one is equal to 7. Now we have sine squared of 30 plus cosine squared of 60. Again, these are given in degree, so we must first interpret these angles in terms of radian measure. And then I'm going to kind of put blanks there for the things that we need to fill in. And we know that the sine of pi over 6 is 1/2, and the cosine of pi over 3 is also a half. So totally I have 1/4 plus 1/4, which is 2/4, or equal to 1/2. Okay, and finally we have the secant of pi over 4 plus the cosecant of 30. So I will write these as reciprocals, and I will rewrite the 30 in terms of radians. So this is 1 over the cosine of pi over 4 plus 1 over the sine of pi over 6. And now that I've done this, I can replace these with the values. So this is 1 over root 2 over 2 plus 1 over 1/2. So taking reciprocals, this is 2 over root 2 plus 2. Okay. So this is just to show that I would expect, or any future teacher would expect you to know how to evaluate such an expression. But I think that perhaps the more interesting thing is some application problems. So these are some simple applications, but believe me when I say that these trig functions have many, many, many real-life applications. All right, so our first example is finding the distance of a ship to shore. A person in a small boat offshore from a vertical cliff known to be 100 feet in height takes a sighting of the top of the cliff. If the angle of elevation is found to be pi over 6, how far offshore is the boat? Let's make a picture. So we have our little boat at sea, right? And we are offshore from a vertical cliff. This is the vertical cliff. And I know the cliff is 100 feet. Sorry, let me get my pen to write better. So we know that the cliff is 100 feet high. And we take a sighting from the boat to the top of the cliff, okay? And we're given that the angle of elevation, so this angle right here, is actually pi over 6. And we are asked to find how far offshore is the boat. So we want to find this distance. Let's call it x because we don't know what it is. We have to put a letter there. So I see now that I have a right triangle situation. And so I can use a trig function. And what I want to think about is the fact that I do not know the length of the hypotenuse, nor can I find it because I only know the length of one side. So I want to ask myself, which trig function uses only the opposite and the adjacent side, but not the hypotenuse side? And so I think the answer that you will find is either tangent or cotangent, okay? Because remember that the tangent is equal to opposite over adjacent. So I'm going to use tangent. It would also be perfectly fine to use cotangent. So the tangent of pi over 6 is equal to 100 over x. This is the equation that I set up, and I can now solve for x. First of all, I remember that the tangent of pi over 6 is equal to 1 over root 3. So I replace it with that value. I don't need a calculator because that's one of my special angles. And now to solve for x, I simply multiply both sides of the equation by x so that I have x over root 3 equals 100. And then to get rid of the division by root 3, I multiply both sides by root 3. So x equals 100 times the square root of 3. And I always include units in real life problems. 100 times the square root of 3 feet is how far away I am. Pretty cool. Okay, we can see a couple more examples. So in problem 6, we are finding the width of a gorge. We're given a picture and we want to find the distance from A to C across the gorge as illustrated below. So what we see is that we are given an angle of 35 degrees, not one of our special angles, inside of a triangle. And we know that the adjacent side length is 100 feet. The opposite side length, B, is what we're trying to find. And again, we have zero information about the hypotenuse. So we should use the tangent or cotangent because we need only opposite and adjacent. As I set this problem up, similarly, I will have that the tangent of 35 degrees is equal to B over 100. Okay, so I can solve for B by multiplying both sides by 100. So 100 tangent of 35 degrees is my exact answer. But because I want to know the answer without tangent in it, I need to use my calculator. Again, that's because 35 is not one of my special angles. So if you have a TI-84, the first thing that you need to do is make sure you're in degree mode. Okay, so because this is given in degrees, hit the mode button on the calculator and then scroll down to where you see on the third line, it's either going to say radian or degree. So you need to make sure that degree is highlighted, okay? So make it so that degree is highlighted on your calculator. You need to change this every time you enter in something on your calculator. And then also, you're gonna have a button, oops, I'm sorry. You're gonna have a button for tangent. So you push the tangent button and then you hit 35 and it'll give you the tangent of 35. Then just multiply by 100 to get your answer. So this is going to be approximately 70.02 feet. Okay, so make sure that you know the difference between the exact and the approximate answer, as we discussed in great detail in section 4.6. And make sure that you only use your calculator when it's an angle other than pi over 3, pi over 6, or pi over 4, because those you can always give the exact answer without use of a calculator. Okay, we've got a couple more real-life examples to go through. Problem 7 is about finding the reach of a ladder. A 22-foot extension ladder leaning against a building makes a 60-degree angle with the ground. How far up the building does the ladder touch? As usual, we'll make a picture to begin with. So I have a 22-foot extension ladder leaning against a building. So this is the building. This is, let me label it. So this is the ladder. This is the building. And then this is the ground. Okay, and then we're given that the ladder makes a 60-degree angle with the ground. So this angle is equal to 60 degrees, which we know to be the same as pi over 3 radians. And the question is, how far up the building does the ladder touch? So the value x we're trying to find is the length of this side here. Okay, so you need to ask yourself, what trig function should I use? I have a right triangle and I know one angle and I have information about the opposite side and the hypotenuse side. So which trig function uses only opposite and hypotenuse but not adjacent? That's sine. Sine is opposite over hypotenuse. So the sine of 60 has to equal x over 22. Okay, so I can solve for x by multiplying both sides by 22. 22 times the sine of 60, or if I want, I can write it as pi over 3, is equal to x. And then I will think, should I use my calculator or not? Well, pi over 3 is one of my special angles. I should not use my calculator. So I should just use the value that I memorized. So this will be 22 times the sine of pi over 3, root 3 over 2. So my answer is 11 root 3 feet. Okay. So let's just do one more example just to make sure that we totally understand this. And then that'll actually be the end of the new material for the entire semester. And then it'll be time for you guys to start studying for your exam. Okay. So in this question, we are given a right triangle. So I'm going to start with the right triangle. And I'm given that it has a hypotenuse of 10 centimeters. We're given that one angle, we don't know which one, is 40 degrees, and we're going to find the length of each leg. So we could call them by, say, A and B. So I'm going to find both A and B. All right, let me try to find B first. Then we can do something similar to find A. So if I forget about A and I want to focus on finding B, then I'm trying to think, okay, so I have the angle, I have the opposite side, and I have the hypotenuse side. So because it's the opposite and the hypotenuse, I'm going to bring the sine in. So the sine of 40 is equal to B over 10. This problem is similar to the problem we just solved. So B equals 10 times the sine of 40. However, 40 degrees is not one of our special angles that we memorized. So the only way we can find what the sine of 40 degrees is to use our calculator. So when I take this on my calculator, I'm able to get the approximate answer of 6.43 centimeters for B. Okay, now let's think how we would find A. So in case of A, I have the triangle and A is the adjacent side to 40 degrees in the way I drew it. So I'm thinking about which of the trig functions uses the adjacent side and the hypotenuse. I'm going to use cosine. So the cosine of 40 is equal to A over 10. So I can solve for A by multiplying both sides by 10. Again, 40 is not one of our special angles, so we make sure we're in degree mode and plug this on our calculator to get the approximate answer. A is approximately 7.66 centimeters. Okay, so that's the end of 5.3.